Good afternoon. Welcome everyone to this final session, apart from the closing session, of today on algorithms. I'm glad so many of you are here in this room. One thing of order you maybe already know, but if you talk, you have to talk through a microphone. If you want to know what happens if you don't, you can look at my video of last year, because then I was for a while talking without a microphone, and then because they're recording it for YouTube. So if you have a question, please use the microphone. Even a loud voice wouldn't help you getting recorded. So we're going to talk about algorithms. I think that's one of the, maybe the most interesting issues these days, also in terms of privacy. The last 3 weeks I was giving a course for data scientists, which I found very interesting. I was offending them once in a while about what they were doing and whether it was ethical or not, because the title of the course was Privacy, Ethics and Law. It was data for data scientists. It was sort of after graduation, postgraduate course for the data scientists. I really enjoyed myself, and I hope you will enjoy yourself also during this panel. I think the panelists will provide enough interesting food for thought, etc. We will be very strict on time, so each panelist has 8 minutes, and after 8 minutes I will cut them off, so that you also have time for discussion. And I'm a silent chair, as you might know, so you won't hear me that much after this introduction. But what I want to do before shutting up, introducing the panelists. I'm Arno Lodder. That's the first. Sorry, I didn't introduce myself. I'm Arno Lodder from the Vrije Universiteit Amsterdam and also Solve Lawyers Amsterdam. And the first speaker will be Jelte Timmer. He's a researcher at the Technology Assessment Department of the Rathenau Instituut. And he combines the insights derived from psychology and cultural practices to reflect on socio-technological developments. Isn't that something? Yes. The floor is yours.
So I'm going to do that.
Oh, sorry, yeah, I will introduce the moderator, because the other speakers they will hear. Shall I do it? Yeah. Sorry for this. I will do them all, then I can stop. So next, after him, will be Johan Verkruijsen. I didn't have internet connection the whole day, so that's why I'm a bit improvising. Sorry about that. I'm also maybe going shake because I don't have connectivity. For over 20 years, manager at Smalls, the Belgian social security in-house ICT operator and integrator, and he is responsible for sales and the research innovation. He introduced with the research team the uses of analytics for fraud detection. Then we have Hugo Jonker. He is an assistant professor in security and privacy at the Open University in the Netherlands. And his research is centered on bringing security and privacy assurances of the real world to their digital live equivalents. His work encompasses theory and practice. And then the last panelist is Frederike Kaltheuner. Frederike Kaltheuner is a researcher and journalist. Her work explores how citizens challenge and resist massive data collection by corporations and governments. And she works on the ERC-funded Data Active project at the University of Amsterdam as a fellow of the Center for Internet and Human Rights. And last but not least, the moderator today, Kyra Sandvliet, who is an independent researcher and also working in practice. She's an IT lawyer, and she pulled this panel together and came up with the topic. So she will do the moderation. She will give you the floor for asking questions. But now, first, and then I will shut up for the rest of the afternoon. Jelte Timmer.
Yeah. Oh, thank you. Yeah, I'm just gonna grab this one. I'm also gonna stand up since we're late in the afternoon, trying to keep everybody awake. A slight disclaimer: I woke up this morning with a fever, so maybe my voice will drop, or maybe I will say really crazy things. If that happens, it's the fever. If it's brilliant, it's me. So I want to share some thoughts about algorithms and algorithmic bias, and how that relates to different modes of how algorithms are constructed. And there was one thing that got me thinking about this. It was is this working? I will walk to you. And it was an announcement by Facebook a couple of months ago that they were launching a new service. And it's a service called M. And what M does, it allows users to send queries to, to the service, and then they get answers to that. Well, at first sight, nothing that special, right? We already know Siri, we already know Microsoft Cortana and Google Now. So what's new, you'd say? But there was something very interesting about this, because when you send a query to M, your question isn't answered by a computer algorithm. Instead, it's answered by a team of humans. So that looks kind of backward, but that is actually really interesting, because these people are answering the questions are continuously monitored in every single action they undertake while answering these questions. And based on that data, Facebook tries to build an algorithm that can eventually answer the questions itself. And why I really love these examples, for me it shows that direction in which the constructions of algorithms is headed in this age of big data, which is learning from human behavior, learning from data, and constructing rules upon that. And I think it's really interesting to see that even a company like Facebook is going as far as to say that they're paying humans to perform a certain trick so that they can gather data about that and then construct an algorithm based on that data. So they got me thinking, what does that mean for algorithms, algorithmic bias, ethics of algorithms? And I want to make a quick distinction between kind of two broad modes, which is a very rough distinction of programming here. On the one hand, we could say we have a more deterministic approach to programming, in which is kind of the classic if this then that approach, in which a programmer exhaustively defines a set of rules that govern what the program does. And on the other hand, we have this more self-learning system, right? The Facebook example that, based on a set of parameters, learns from a training data set and discovers its own set of rules. And I think these two different approaches also result in different types of biases. So when we look at this, first, this deterministic model, right? We're trying to define what the program needs to do. Then obviously the source of bias where we're going to look at is the programmer. So we're going to think about how we should teach these programmers a crash course in ethics. And while I'm really a big supporter of that, I also think it is important to stress we shouldn't overestimate while we're trying to demystify the algorithm, that we mythify the programmer. So as a critic Malte Ziewitz has noted, we shouldn't conceptualize this programmer as a lone decision maker that makes all the decision, puts it in a program, while in fact reality is far more complex. And I'll illustrate this with a small example of self-driving vehicles, which have become, especially the ethics of self-driving vehicles, which have become like a popular cocktail party discussion theme, if you ask me, which have led to like a modern day variant of the ethical trolley bus dilemma, right? You have, in case of an inevitable accident, you have to the program has to make a choice whether to run over a child or an elderly person. And while this makes very interesting cocktail party talk, I don't think it's very representative of what actually will be happening, right? In reality, this system will be far more complex and consist of multiple interacting layers of programs. So there won't be such one programmer, one lone decision maker making the shots. In fact, there will be interacting systems that will, through that interaction, also behave somewhat unpredictable. So we can predict upfront what the ethical consequences of such a program might be. Now moving on to this other mode I mentioned, so non-deterministic programming. I think this is interesting because this already more reflects self-learning programs, this sense of complexity, this sense of the system learns itself, discovers it, rules itself, and so that shifts our focus of where bias comes from as well. If we look at this, there's several examples. For instance, in recent years, we've gotten really good at face recognition systems, right? They're better than humans, something computers were really bad at. They're better than humans now. And the main reason for that is that we have swaths of data, swaths of human faces that we can use to train our algorithms. But if in that training data, for instance, white people are overly represented and colored people are less represented, the algorithm is, of course, going to have more trouble recognizing and identifying people of colored skin. So the data will be very important in how, how the algorithm will perform. And another example, which is really telling, that I want to put out here as well, is comes from St. George Hospital Medical School, which I think already in the 80s tried to make a program that did the applicant selection. So they wrote a program that could, with I think somewhere around 96% accuracy, replicate the results of a human selection committee. So I thought, well, great stuff. Let's have the algorithm do the first selection rounds. But what happened is later, when some researchers took a good look at that program, they found out that the historical data the program had been trained on actually contained strong biases towards against ethnic minorities. So ethnic minorities were systematically excluded from job interviews. So I think this really shows the importance of, we're kind of finishing, we're doing on time? Great. This shows the importance of where we look for bias in terms of data. And closing up, right on time, I would like to note that for me, I think it's important that we acknowledge this complexity in thinking about automatic decision making and how we should think about bias in that. And I want to close off on a happy note as well, because the complexity usually is seen as very much a problem. But I also read recently an announcement by IBM that they had developed a system for their self-learning computer, Watson, called Watson Pods, that defines a virtual audit trail. So it shows how it made a certain decision. So I think if we really put our foot down and really imply that it's necessary to make these, to create these insights, I think we can create it as an engineering challenge rather than a fundamental issue that might hamper the development of these self-deciding systems. So that's my wrap up. Thank you.
Ja. I think we're moving on to the next speaker. Thank you, Jelte. I'm not talking in the microphone. Sorry. Sorry, Arno. Thank you for that. I think we can continue with Johan if there are no urgent questions in the room already for Jelte. Then we can keep your questions for after the rest of the panel. We have to bureaublad. Kan jij helpen? Hij staat helemaal links. Ja.
I think we're still in my thing.
Yeah, we need to close a few things.
Yeah.
All right. Some technical problems in this technical panel.
We would like to discuss algorithms, but PowerPoint is already...
PowerPoint is objecting. The computer says no already.
Okay.
Yes.
Okay, thank you very much. I will start. Where I come from, this is Belgian Social Security and the IT functions surrounding that. When we think about algorithmics, we think about very practical use, about things that we can put into processes and to procedures that have return on investment, that we can show to the government that the euros that they invest in these systems, that they report something. So from our point of view, a computer with a bunch of data and algorithms, it's nothing more like a machine. And for us people to use. And the question I see for this panel is, if you get hit by the machine, then do we ask the machine to explain itself and what happened? And at first sight you would say, yes, people have the right to know why they were hit and they have the right to understand, but it's not that easy. And to see why it's not that easy, perhaps we should have a look at how we, in our case, in Social Security, we are building models to fight fraud. Well, it all starts with business input. Really, we tried to let the machine do something, but if we didn't start from people and from their knowledge and their intelligence, we didn't get nowhere. So it always starts with business input. People from the field who have a hunch, who say yes, maybe, if, etc. It always starts with that. And then the data scientists, well, he has his lots of data, and he has his computers, and he has a little hunch of where he should go, and then he starts to work on it and goes back, etc. Finally, when he himself is satisfied with his results, then he goes back to the business and say, look, this is what I found. And businesses say, oh, no, it's not that. And so they have a number of iterations until in the end, so, okay, it's good enough. And the big boss said, let's do it. Let's hit upon that, etc. So what you really see from this simple representation is that with algorithms alone, you can really do nothing. Algorithms alone explain nothing. You have to need the implicit business knowledge. You have to have the data. You have a number of algorithms. You do not have one algorithm. It has been said you have several systems, but in a single model, in a single system, you have a number of algorithms you use. So this combination is rather tricky and rather difficult. And each and every single one of them is already so difficult that if you have to give it to normal people, that it is impossible to understand. Even worse, they change. For instance, if you have a model with a given set of algorithms and you change the underlying data set, the model entirely changes its behavior, its prediction does change, etc. So both are married. You really need and the data and the algorithms and even the context in which it happens to understand it. So it's not practical at all to try to give feedback, to give transparency on algorithms to common people, let's say. I do not say that in extreme cases you could not go to an expertise or a study or etc. But well, that's perhaps 1 in a million times that you will be able to do it. It will cost a lot of money. You will have results after years, etc., etc. So if you have a car crash with a number of people dead, maybe you will do the effort. But in general, for normal cases and for administrative cases, you will not do that. I have developed a number of examples of how we use analytics or predictive analytics to fight fraud. And the first example is rather straightforward. Okay, we just take these data. We have the models developed after a number of feedbacks, and we think it's good enough. So we select the places, the employers, because this is employer fraud, not paying social security contributions. And we say, okay, these are the guys we think might be fraudulent. And then we just, from the thousands of cases that sort out, we just take the top 100. Why the top 100? We cannot do more. The audit services, the inspection services, they cannot handle more than 100. So, okay, the inspectors, they take it up if they want to, because some of them say, no, I'm better, I'm smarter, I do it myself. Or they do a mix, they do some of them, etc. And then, but with a bit of pushing, they do the audits and they come back with the results. And with the results, we get a better model. What the first thing is that you see there is human intervention, and there is even a possibility for humans to decide if they are going to take it or not. And the human intervention is giving feedback to the system. The second case we use it is what we call the risk profile, and that's an entirely different way to do it. In this one, in the risk profile, it is again about employers. We try to make a profile. How much chance is there that this employer is not going to pay in the future his debt? How much chance is it that it is a fraudulent employer? And that's what we call the risk. If he has a very green profile, so he's very low risk and he's very of good faith. So if he doesn't pay in the future, he will receive a gentle phone call, say, oh, you missed your, please pay attention because, etc. There can be consequences, but nothing will happen. If for the others, on the other hand, he is rather red, it's fraudulent, likely, and he's very likely not to pay, etc. We send immediately the lawyer, and he receives a receiving order, taking immediate action upon his goods, etc. So the most severe action is taken in order to avoid that Social Security loses money there. So this is an action, but The way it is done is not immediately from analytics or from algorithms or from data. What we do is we use a number of in-between parameters. Let's say 6 of them are already existing parameters who have been time tested, used by hunches, by the intuition of the people of the business. And there are a number, 10 or 15 new parameters. The entire mix is then pulled through the mill of the analytics, and then it say, okay, that parameter on that value for that weight is going to help to decide if this guy is fraudulent or if he is not. And this is how we do it. And then what we do with that is just turn that into policies. What you see is, so we use this analytics, we use this data, we use these parameters, and then once we know that, we say, okay, from now on, if you are an employer, and if you are red, okay, if you are red, then from that moment on, you will achieve that punishment. And this has the big and major advantage that, okay, all people are treated equal. You can give reasoned decisions, so you can explain why you take it. And it is, as it was not done before, it is evidence-based, and that's what you get with analytics. I guess, and I will stop it, we have the occasion during the discussion. In the third case, what we were considering, but we have not done it. We were considering really at that point to have an automatic retrieval of rights in case, because there was a spreading in the network of Social Security of false data due to fraud. And in that case, we said, okay, what we should do is use complex event processing. That were the technicians, but our people from the business say, no, we do not like to do that. We try to avoid it at all points, etc. So in administrations, it is really not today the mindset that we should let computers decide. Legally, they cannot do it, but even they do everything to try to avoid it, and this is what they did in this case. All other issues being for our next discussion.
Thank you, Johan. So Jelte suggested to empower or enforce more transparency from the engineering source, if I'm correct, Jelte, right? And Johan, you were suggesting that the transparency isn't really that necessary because, well, it won't find...
I'm more suggesting that it doesn't make any sense. It's not understandable by people. It's taking a lot of energy. So I do not say we should not create transparency, but it will be reduced to very valuable moments at any moment because you cannot afford it. For normal people, it will have no meaning. So we should maybe find in between means to give feedback about the system that is used. For instance, but we are already in debate. For instance, you could say we are going to certify processes. You could say, and then the feedback is the process is certified, and within certain limits, you know that you have a good process. We are not dealing with snake oil here. This is something we could do.
Okay, thank you. Hugo, the floor is yours.
Excuse me while I stand up. Put it on, switch it on.
Yes, there we are. Okay, so following the example of Jelte, I figured I'd just stand here so that you can see me. Thanks for the invite. My background is maybe a bit different. I'm a computer scientist, so I looked at the questions for this panel a bit more. What is an algorithm anyway? An algorithm, I don't know if you, for those of you who notice this is boring, it's a recipe. Now, if you have ever cooked, then you probably have a clue on how trustworthy recipes are. If you've ever had, you know, mushy pasta or way too hard pasta, then you know how good that goes. So, but it's just a recipe. It's got ingredients, it's got actions. It's not scary, but we do it on a computer. Well, okay. So, here's an example. This doesn't look so scary, does it? I mean, if you know computer science, if you don't, it doesn't look so scary. It's like 5 lines. This is from Euclid's algorithm, by the way, but okay. These things are used in all sorts of places, and sometimes you don't know where they are used. Sometimes you don't realize that they are used. Hotel booking, travel planning. When I came here, that's on the next slide. I came here using algorithms, and I trust them completely. So, but let's keep in mind, algorithms run on computers. Computers have limitations. Now, these are things you may not have seen before. First up, Dijkstra. Testing shows the presence of bugs. It does not show their absence. You cannot test a program and say, look, it works. You can only test a program and say, look, it doesn't work. This is an important thing. You don't know if the program works. You can only, if you test it and it works, you have proven that it worked then, this one time. And then you can run the test again, and then you have two proofs. But you don't have a proof that the program works, not by testing. Secondly, security protocols, my hobby. Security protocols are famously 3-line programs that we still manage to get wrong. I don't know if you've heard about things like the go-to fail or hard bleed, if those things ring a bell. But so in 3-line programs, we get things wrong. If I go back a bit, this was a bit more than 3 lines. And this was a really simple algorithm. Yeah? So, a thing to keep in mind, another thing to keep in mind is not just limitations of computers, limitations of algorithms. You put something bad in, you get something bad out. If you put a salmonella chicken in your dish, you get out sick people. But if you use a cutting board which has salmonella and the rest is clean, you also get out sick people. And this is kind of the tricky bit. Your input needs, your algorithm's result is only as good as its input. And this is a thing that Jelte was talking about also. We are now moving towards this big data, these adaptive algorithms. Traditional algorithms, as computer scientists tend to see them, they are static, like the ones I've showed you. You know, these 5 lines, they don't change. However, for example, DNA sequencing, sometimes used in courtrooms. I checked, Google Scholar found scholarly articles, 110,000 in 2015. Now, I'm sure like 80% of them was not about innovations to actual DNA sequencing. It just happened to have those words in it somehow. Maybe it was 95%. That still leaves more than 1,000 improvements to the technology of DNA sequencing that your static algorithm is not including. Third thing, scope creep. This is the same algorithm as before. It does a little bit more. The customer said, oh, that's nice, can it also do this other thingy? You get this. So, I don't know, I thought the previous one was pretty legible. To me, this one is getting a bit bad. It gives the same output and a bit more. So this is also, we make an algorithm and then suddenly we expect more from it. You know, we make an algorithm for a paternity test and suddenly we go to a court case where we say, well, the paternity test proves that he was there. That was not what the paternity test was made for. This was completely different. This is not the right algorithm used. So, I was thinking about this and I wanted to share this with you and with the panel. How can we think about this? I figured some use cases where you use algorithms. Traveling to this conference, DNA sequencing in court, making a medical image. So, making a medical image, if you think about usage, this is really, it's almost funny to me as a computer scientist. I'm thinking about, like, there are sensors, they give me zeros and ones, and I make, you know, some lights on the screen, roughly said. And then the next person is a person who worked 8 years towards a medical degree, and he says, oh, and now I can see where there's cancer. This is not what I'm thinking when I'm putting this data together. So I'm thinking of this algorithm, the top one, And the doctor actually thinks I made the bottom one. So there's already a fundamental problem there. Power of algorithms. I used these two algorithms. This is a train planner. It's a nice one because it doesn't have all the extra info. And this is Google Maps to show me how to walk here. I completely trusted them. Did anyone else do similar things? Yeah? Is there anyone in this room who actually, bought a map to find out how to get here? No. So everyone here probably trusted information you find on the internet, and that makes an algorithm. Should they be used? Absolutely, in all cases. It doesn't work otherwise. But the traceability is a bit of a problem. Or is it? So, usually it's a black box, but if we have just one party running the black box, they're responsible anyway. Is the outcome sufficiently traceable, however? No. No, it isn't. I have no clue how the train scheduling works. I get in a train if I get here, I'm happy. If I don't, then I'm upset. We don't need traceability. That's what Johan was talking about. We need accountability. If I don't get here on time, I say, hey, railway services, what's up? Conclusions, algorithms are tools. We shouldn't think of them as something else than tools. Blind trust in tools is wrong. I mean, if you have an electric chainsaw, you don't trust it around your toddler. If you need expertise, you get an expert. If you have a DNA sequencing happening in court and you want to contest it, you get an expert. You don't try to understand it yourself. Finally, you don't give, what I just said, you don't give a Stradivarius or a chainsaw to a toddler and expect things to go well. Thank you.
Thank you, Hugo. I'm curious because you say you need an expert. So if we talk about algorithms and putting some data in and getting some data out, you understand what's happening. I absolutely don't. I think a lot of people here also don't. But the expert, if he has to say something about why A was put in and B was the result, doesn't he need to know what happened? Do you understand my question? Sorry.
Yes, he does. Yes. So yes, the expert does, and that's actually why you need different expertise for making an algorithm than you need for using the algorithm. Compare this again to tools. I don't know how many of you can make a hammer. I can use a hammer. Using a hammer is different from making a hammer. Using a saw is different from making a saw. Making an algorithm, you need some expertise for. You need to understand how computers work, how algorithmics work. Using the algorithm requires understanding where its inputs came from, understanding the limitations of the algorithm, understanding the limitations of the input. Like in the DNA example we had on the slide somewhere, this is done using sensors. What happens if those sensors malfunction? What happens if they malfunction a bit? I mean, this is the real world. Nothing works 100%. Everything works like 98%. Right? But if your algorithm doesn't know about that. So you need someone who understands that, and that's not a computer scientist.
Mm-hmm. So, wouldn't you suggest that you would need both to understand the fact that there's something malfunctioning?
Absolutely.
And yeah, okay, good. Are there any urgent questions before we move on? No? Good. Then the floor is yours, thank you.
Thank you very much. I'm quite happy to be speaking after Hugo directly because I'm going to add a little social science perspective on the points that have been made previously. I think the public debate about algorithms has been going on for a couple of years now. And, but it's quite interesting that we always see the very same examples. We talk about self-driving cars, credit scoring, predictive policing. So in fact, algorithms have become such a hype that there has been a fake article in the fake news outlet, The Onion, making fun of exactly this debate. So why I think it is very, very laudable and important that we are talking about the topics like automation, algorithmically driven decision-making, machine learning and analytics in the context of ethics, policy and normative questions, I do think that we need to spend a little more time taking a step back and asking what actually are algorithms, what is it that we're talking here? So what is quite interesting about algorithms is that people use very different definitions. This is a point that has been made by Jelte in 2014 already. For software engineers, algorithms are often quite simple things. They're a computational procedure to solve problems, or as Hugo said, they're a recipe. For the broader public, however, algorithms are something very complex, but at the same time elusive. We talk about the Facebook algorithm or the Google algorithm. And then, in addition, social scientists are also fascinated by algorithms, but for them, there are inscrutable artifacts that nevertheless have explanatory power. And here's a little side story on this. I think it's also important to note that the meaning of algorithms has changed over the last years. This is an advertisement from the search engine ask.com in 2007, where they tried to put the word "the algorithm" in the public discourse. This case has also been found by Kyra Sandvliet in a recent article on algorithms. So my suggestion for the questions that are relevant in this panel, I would like to suggest that we drop the word "the algorithm" and instead approach the problem as a form of socio-technical assemblage. And that sounds very social sciencey, but what it actually means, and here in the background you see a social technical assemblage of YouTube, is that algorithms function in a very complex system of people, of human, of non-human actors. So whereas we can talk only about the algorithm, in fact we talk about algorithms in the plural, models, target goals, data, training data, applications, interfaces, hardware, designers, engineers, managers, companies, you can even add capitalism or the social science system these companies operate in. I think this is important because those are all different points where values come into play or normative questions. And in the context of this panel, we wanted to address the following question. Where are algorithms currently deployed? Where should they not be deployed? And should algorithms be made more transparent? I think if we drop the word "the algorithm" and instead talk about a complex social technical system, there are 5 very interesting insights. So the first of all, if we drop the noun, algorithmic becomes an adjective. So algorithmic is more a mode of making a decision rather than you have either human decision making, which is subjective and soft and good, versus the cold algorithm. In algorithmic decision making, humans are always involved. At the same time, human decision making can also be algorithmic. Think about, for example, bureaucracy as sort of like a system of procedures which make decisions based on very clear and simple, clearly defined rules. But also in machine learning algorithms, there are humans involved. It's not that the algorithm itself has an agency. It does, but there are also decisions that have been made by humans. So the question we have to ask is, where do we want this kind of algorithmic decision making? It can be a good thing, it can be more impartial than sometimes humans are, but sometimes we maybe do not want this kind of decision making. And we also have to ask, is there something unique about algorithmic modes of decision making that cause unique problems? The second point that changes is data. If we drop the algorithms, we have to pay more attention suddenly to data. This point has been made before. David Leon said this morning, data collection itself is not harmful, but only their analysis. However, I would add that the best algorithm is useless if the data quality is poor or the data is systematically biased. If we talk about the algorithm, we forget that if the data is crap, then the algorithm is crap. So the third point is we can only employ algorithmic decision making if we ask the right questions. Again, this point has been made by Hugo, and also recently by my colleagues Jonathan Gray and Caroline Gertz. We always talk about data literacy, but we don't just need more awareness of how data are worked, but also sort of the systems in which they're being produced. For example, the best example here is if you use Twitter data in order to find out what the population of the Netherlands or Belgium thinks, this is not the kind of answer you can get because only very particular kind of people are on Twitter in the first place. And Twitter has its own very obscure ways of generating these data, even though they're publicly available. The other point is power. One question that was also posed in the introduction of this panel is how much power does the algorithm have? How decisive are decisions by algorithms? And again, I would say the algorithm has only so much power as we grant it. And it depends. Sometimes algorithms are used as the main decision maker, for example, in algorithmic training. Sometimes algorithms are more auxiliary tools. And the outcome or the potential dangers are very different in each of these cases. But always, whenever the algorithm is not making a decision, as in automatic trading, there's a human which takes in the information of an algorithmic decision-making process and then again judges, is this information useful? Should I actually act on this information? So to sum up, I think the algorithm is a noun that's not very useful, but we should talk about it as a complex system involving human and non-human actors. And the main advantage of this kind of approach is that we move away from transparency as the only solution to the actual problems that are posed by algorithmic decision-making. For example, algorithms are discussed in the context of very diverse problems. We talk about discrimination in the labor market. We talk about errors that are made in financial trading. We talk about the Facebook experiment in the context of algorithms. We talk about predictive policing and predictive privacy harms. I believe that these are very, very different problems with very, very different arrangements of a complex social technical systems, and hence each of these problems require a different solution. For example, we can think about norms and ethics and train computer scientists and data analysts to interpret the decisions that are made in an algorithmic context more carefully. In cases like the Facebook experiment, the problem might not be that there's an automation going on, but that there's a concentration of power. We'd have to talk about accountability, reporting, and audit studies. That point has also been made by Hugo. There's also the possibility of notified users or procedural due process, and one can even think about direct regulation of algorithms. So I'm sorry if I'm not really producing or proposing a solution, but I think as long as we talk about algorithms in the singular, we underestimate this is a very diverse problems and which require very different solutions.
Thank you very much for that insight. I think we have a very diverse panel with diverse presentations and actually pinpointing different problems and actually pinpointing different solutions. And I see that, so we can focus a bit on making it more transparent by giving the example of Jelte. I think you were referring to the IBM system?
Yeah, well, it's not necessarily like transparent for everyone, like Johan also mentioned. I think you need to have different levels of transparency, right? I don't think every single user should be like able to, I don't know, get into the inner workings of how a decision is made. But you should have some level of control, of accountability, some system to, achieve that accountability. And I think, like a digital audit trail kind of system might be very useful in that. And the fact that it might be complex shouldn't be the reason why you don't do it. Like data science can be complex as well. We still do it. You just have to the right incentives, have the right incentives to do that.
I think Hugo really wants to say something. You may.
So I'm wondering, could you still call it transparency if it's so complex that it's basically not transparent to an average user anymore?
It might not be transparency, but it might be accountability or something like intelligibility, right? So, because just plain transparency is, if I just give you a bunch of data or a very complex algorithm, I can't read programming. So yeah, that's very transparent, but it isn't useful at all. So I'm not that big a fan of the concept of transparency. Rather, I think Frank Pascal also notes this. He talks about the concept of intelligibility. So I don't think everyone has to understand exactly how something functions. But yeah, if you make a decision about something, for instance, a drone pilot making the call whether to fire or not, yeah, you should have more than just the computer says this might be the guy with 80% accuracy. Yeah, make the call, go for it. You need to have more information to be able to make that call.
Yes, I'm Patrick Pennings from the Council of Europe, Information Society Department. In fact, the Committee of Ministers of the Council of Europe decided that we would look into algorithms in internet or in electronic decision making. I think the key is not so much into the technicality, but much more what use is being made, what are the underlying grounds. For example, well, Facebook algorithm was mentioned. How and are data being used in order to, through algorithms, sell us certain products or promote certain products or whatever. I think the societal aspect and the background and the decisions that lay at the origin for the installing of algorithm is probably more at stake than the algorithm itself. It's a question to you. And maybe also a second question, what should we be looking into specifically?
If I can jump in here. Something that's talked about a lot, there are a lot of different algorithms that are used in Facebook, but one example that's always used is the Facebook Newsfeed algorithms. Especially younger people get their news primarily from social media. So this makes something like the Facebook Newsfeed algorithm extremely political, because it can determine what kind of things people learn about and when. But at the same time, sort of, when newspapers make the decision what to put on the editorial, you could say that there's also an algorithm at hand. There are criteria for deciding what is relevant. And in the Facebook context, this is made in an automated way. But maybe the bigger problem in that context is more that there's only one source where people get news from, which is one single company. And in this context of a newsfeed, disagreement from the audience, what I would like, it's like, this is a sorting algorithm. Whenever you have massive amounts of information, you always need somebody who sorts it. But this is a very different problem from the problem of when you make a hiring decision, I would say.
I think I would add that we kind of had the conception that there might be something as a politically neutral kind of algorithm, but of course there is not. It's always going to be a political decision. If you look at Facebook, but also if you look at Twitter, what becomes a trending topic is, that's essentially a political decision whether you value recency more over another, over another value, just pure mentions over time. So it's inherently political, and either way you turn it around is going to be, it's going to be political.
So I wanted to thank Frederike for her input and the focus you've been making on the problems of the concept of algorithms. I think that's very important. Also because I have the suspicion that talking about the algorithm, we sort of look for a replacement for the human being as the responsible rational actor to which we can attribute all the responsibility. which does not work, as you beautifully pointed out. But I wanted to ask you, what are the consequences of that more concretely? Would you say that rather than looking for transparency and accountability, we just have to accept certain dependencies which you cannot get rid of? Is that what you're saying? And deal with those dependencies, or do you propose another way of approaching that problem?
So I basically propose two things. One is to make a differentiation between different algorithmic problems and not lump them all together. And the second one is to carefully find out what are the unique problems of algorithmic decision making. The best example here are hiring algorithms. People discriminate in hiring situations. This is a very well illustrated and proven fact. What is different when machines scan CVs? Is this kind of discrimination that happens in these cases very different from the way that we discriminate? And I think the answer here is yes. And the main difference is that it becomes a lot more difficult to prove whether you have discriminated. Because when you make an algorithm that just calculates who's the best employee going to be. What if you use proxy values? For example, it's very easy to have classical categories like gender or race get slipped into an algorithm and you automatically sort out certain kinds of people, but in the end it just looks like you hired the best person and you did so in a very neutral and objective way. And I think it's not a new problem, but it's just the problem works in a very different way in that context and needs maybe new regulation.
May I? Thank you. Ian Jenkins from Panopticon Foundation. I want to just give you one example of very interesting case of algorithmic decision making. It was law introduced in Poland 2 years ago when public employment services are now they are giving public services according to algorithmic decision making. The process is totally not transparent, and we are now thinking what kind of safeguards we can put into the law, because, for example, data protection law is not giving, in this particular case, enough safeguards, and we came into this mind, according also to the Daniel Citron writings, that maybe we need some kind of oversight from data protection, but at the beginning of the algorithmic, when the algorithm is made and was developed, or maybe the DPA, they do not have enough power, maybe some kind of independent anti-discrimination body like Ombudsman National. We don't have any now any particular ideas, but maybe you can give us also some advice at the phase of designing what kind of safeguards you can maybe, or we can have to, we can advocate for.
Yes. Currently in Belgium we are not using such an approach, deciding on social rights. There is something similar in employment, but that's a positive way. That's the matching between job seekers and jobs that is doing, and there we are just enhancing the chances of people. But if you have social rights depending on it, it's more tricky. But what I would guess, if we should have such an approach for any reason to get enhancement by algorithms, that we would look feedback out of the system, that we would like to say, okay, in this case, what is coming out of it, what was the result, and with some statistic approaches say, okay, in this case, is this defendable? Does the system as a whole is acceptable? I think this will be more feasible than trying to dive into it and to master the complexities of the system.
I'd like to follow up on that. What Frederike said before, you should also keep in your mind, and that might help. If the data is bad, then the algorithm is not going to perform. And a point Jelte made, which I think is also very important here, in this case, is if the data you're using is biased, you're going to end up with a bias. The algorithm is just going to reflect the data. So bad data, bad outcome, biased data, biased outcome. And there's something that maybe a data protection authority could, help to make sure the data is less biased or less bad.
So since we're referring to each other's talks, I would like to put in my 2 cents as well. And I think it might be interesting, because Frederike mentioned, well, some of these processes are actually quite similar to what we know in bureaucracies, right? Bureaucracies tend to be very intransparent systems, tend to sometimes dehumanize the subject of the decision making. So maybe that's a context we can look at and learn from how to improve these more algorithmic decision making systems. Because yeah, they are also, in some sense, they are also formulas, right? Someone in a government office gets just a selection of numbers, and if it's in this category, he decides this, and if it's in that category, he decides that. So there might be some interesting avenues for learning.
Hi, Brendan van Elsene from the University of Leuven. I have a very practical question, maybe a very simple question, which relates to Johan's example of the use or the development of risk profiles in order, if you have a suspicion, to determine whether somebody, is good faith or bad faith, or and these types of things. And as an administrative authority, when you decide as to the appropriate measure, where you either send them, a kind letter of warning, or you actually decide to instantly fine them, particularly in the latter case, I would imagine you have some type of duty to motivate a particular decision. And how does, the algorithmic process that underlie that, does that translate at all in any way to the information given to the individual concerned? Thank you.
Okay, the big idea is here that it's not the algorithmic process that takes the decision, but that it is translated into a policy. And a policy based upon a number of variables, and those variables are then put into rules. And those rules are discussed on the proper level. For instance, at the highest level of the Agency for Social Security, and where employers and representatives of employees meet, and they decide, okay, this is the policy we are going to install. Starting from that point on, okay, it becomes very simple. You have that much points on that, you have that much point on that, you have that much point. And that's an approach that has been followed for 30, 40 years already. We are giving good scores, bad scores to employers, but those scores, they were based upon hunches. There was no let's say, evidence-based, not whatsoever. It was what the administrators felt that was correct based upon experience. Now what we are doing is more or less the same approach. People are in between, so if there's really something odd, they can intervene. It is approved by higher levels, so it's a policy. It can be explained because you have those and those and those and those parameters. The system behaves more or less the same in all circumstances, which you do not have if you have algorithms. You can have a butterfly effect there, just a tiny bit of difference, which for people would make no difference, but the system takes an entirely different direction. So this is switch and goes. It is, in matter of fact, a traditional bureaucratic system, but evidence-based.
And in a computer.
Yeah.
My question is, to what extent are these inputs and these policies and these rules made explicit to an individual who is faced with a specific
Normally
decision?
in certain cases, and particularly with regard to the receiving order, which is a very harsh decision, then there will be a motivation. And I don't know if it will be always signified, but the motivation will be available. So administrative decisions must be motivated, but even in this case we can create motivation by computer. The only thing is, do we want the computer to have the last word, or do we have an agent look at it and sign the paper, say, okay, I approve this, this is my decision according to the rules, etc., etc. You should know that a lot of decisions already are taken by traditional programs, sending out papers, nobody sees it, etc., and it is taken for that. Otherwise, the system wouldn't work. It's already the case.
So, Johan, I have a question following up on that. So, how? Because the system works essentially with parameters. So, but of course, a parameter is a representation of a certain behavior. So, how do you deal with false positives or false negatives in that system? Is there a certain? Do you have a certain threshold? Is it like, okay, you can't employ a system if it has a certain number of false positives or false negatives?
Well, the system of profile is still in development, so we have to see what we have foreseen is a feedback mechanism, and to see that if things really go wrong, that we can correct. That is one thing. And the second thing is that we have a rather large margin of error. Anybody of you who's been driving in Belgium, you can get flashed. You can get flashed in your country too. But if you get flashed in Belgium, you get a bonus of 6 kilometers per hour. This means that up to 6 kilometers, you get no penalty. And that's good for trust, because people know that if they are flashed, that there's no way that they were not speeding, because this 6 kilometers creates trust that there is no error on the side of the system. So this kind of thing will be involved in such a process too, getting enough error of margin so that if we say, oh, very bad outcome, then people are sure that it is like that.
Yeah, if I may, very briefly, it's just one step further this problem of how to use, how the people use algorithms. In the Polish example, I was astonished by this figure that only in less than 5% of the cases, the employee that had to do this algorithm challenged the results of the algorithms. And this is one of the issues. Border guards or any kind of employee that feel that the result of the algorithm is not right, how he or she can challenge and be safe, because I think that this raises some issue. The second problem of if you put bad data, you have bad results. This is clear, but in my experience, in many cases, the public administration is so eager to have these new tools that look so modern that if you can many times hear the comments, but data will be better in the future. But then, can we have this? And I have participated in a kind of experiment that it was quite fun. It was about the safety of the neighborhood. And because of the data that the municipality had, the result was that if you had a Spanish neighbor, the safety of the neighbor was better. That it was very good, like for the Spanish people and Spanish-speaking people. But of course, it's a trivial example, and it was so trivial that at the end it was okay. We cannot use this tool. But there are several issues on this.
Okay, so this ties in with a remark that ties in with your question and the Polish case, I think. Again, your first question. How do we challenge? I think we should flip it around. I think how do we challenge the result of an algorithm is the wrong question. Extraordinary claims necessitate extraordinary proof. Same thing for algorithms. This doesn't change if we suddenly use a computer instead of humans. So if we have a more severe outcome, for example in the Polish case where this impacts social security, if the result is more severe, then we should require the system to give us more proof, which is, I think, exactly what Johan was saying, basically. If they are going to take more severe steps, they are going to be damn sure that this is really the case and that it's really warranted. So that would be also my suggestion for Poland. But flip it around. Don't say, okay, the algorithm said something, so we're going to follow it. No. What did the algorithm say? And if that impacts people, if that has a stronger impact, then we need to understand this better before we accept it.
And this plays in on the level of discourse as the ask.com advertisement. The purpose of this was to make the point that algorithms are neutral and objective. If we in general, as a society, blindly believe in decisions made by computers, we're not going to challenge them, and this happens at every level, also in the places, in bureaucracies where decisions are being made by designers, etc.
I'm sorry to come in again, but in a way, I think the discussion on the algorithms, we need to connect it to the topic of the conference, which is privacy and the use of data. I believe it's not so much the question of if we type in the name of the place here and try to find the best way to reach it, that in itself is not an issue, and it's not whether the use of that algorithm to get us here is important or not. What I think is important is that the fact that a number of other data come into play, which I, in one or another way, have displayed on the internet. I was maybe looking for a hotel, and I get a number of proposals. I'm walking, it's about dinner time, and I'm walking past restaurants or so on. What I'm trying to say is that you're referring to examples of where you voluntarily bring in data on which an algorithm is applied. When I want to apply it to the privacy issue, then the question is to which extent data for which I have not necessarily given my consent are being applied to not only give me the train table to come to Brussels, but also gives me another number of things which I have not asked for and which are, in a way, put onto me. And that is where the societal questions, I believe, come in, and the privacy questions come in. And it's maybe not the technical discussion about how do we create an algorithm, but it's the decisions behind the creation of the algorithm and what is being used in terms of our private data in order to feed the algorithm.
Is it directed to a specific speaker, your question? Yeah. There's great work on this topic has been done in the US, and I think the lawyer can maybe elaborate on this. There's work been done on... I wasn't looking at you. On predictive privacy harms, and that in the US legal context, the concept of due process could be of use. I'm not sure in how far this is as applicable in a European context, but I do think that people talk about algorithms precisely because so much is at stake. Predictive privacy harms is you provide data which might not necessarily be discriminating, but then through predictive analysis, the analyst finds out that you might be pregnant or that you could be homosexual, which is an information in itself that you have never provided. And exactly in these kinds of cases, there's the question not just if you're affected by such a decision, how can you, first of all, know that this decision has been made, and secondly, how can you criticize and challenge this decision that has been made by an automated decision-making process based on random data you don't even know about? And this is also the case in hiring algorithms. I met people from analytics startups in Berlin who use data you found about you on the internet, so anywhere, they couldn't even tell me where, to make a personality profile in order to assess whether I would be a good candidate for a job. And this is a very, very sensitive area where privacy is extremely relevant.
Okay, maybe just 1 second. I like very much the example of the hammer, because we could look at all new technologies, be it algorithms or other, like a hammer, and it's not that much about the hammer, but what you do with it. If you hit people on the head with it, maybe we should look at that, and then after time,
please remain seated.
What we really should do with the algorithms, then of course, more or less, that will be more clear if you have all the cases of hitting people with hammers.
Maybe I can add to what was just said. When I asked, there's someone in the Netherlands who is thinking that privacy only comes into play when you have the results of data analytics, of big data analytics. And I asked those data scientists, do you agree or not? And there was some discussion, but in the end they all agreed that it starts with the data. And that's also what they discussed. When you're collecting the data, you need to have the purpose in mind, why you're doing it. And already then privacy becomes relevant. But privacy is also relevant for the algorithms that you design, and what they do and what they do not. So privacy is in several phases of the process relevant.
Just a quick comment on the hammer, because this comes up so often in technology panels. I mean, we've been talking here about a hammer which is better to hit white nails than black nails, for example. this is not a matter of just what you do with a tool. It's not a neutral tool. And it's not a matter of what you do with it. If you have a hammer that is better for hitting white nails than black nails. To put your analogy further, I just wanted to add that.
Okay. I do not want to reduce the discussion. The only thing I say, if you are in frontier technologies that you do not know very much what it's doing, how it's working, etc., that one way to consider action is to look what is happening with it and how people use it.
Just very briefly, Andreas Gothi from the Technisches Bürgernetzwerk, Austria. Since we're heading for a party, a long party, lasting until 4 a.m., let me dampen down a little bit the humor and just inform you that there are already 3 countries in Europe where an algorithm decide what sum the tax office can assess you. Please notice it's crucial, the semantics. Assess you, not audit you, assess you. It's decided on the basis of an algorithm which inverts the burden of the proof, which means that once you simply receive the notice for the sum that's been established by an algorithm that goes through all the databases that affect you, your expenses, it's non-anonymized, and this happens in all these 3 countries. These are European Union countries. And what you can do is, of course, you have legal recourse. Good luck with that. And good luck with proving a negative, which, as we all know, in criminal cases is constitutionally forbidden in most developed countries. So much for optimism and big data and algorithms. Thank you very much.
Yes.
Okay, thank you for that last note. Maybe we can wrap up. Are we wrapping up, or do we have one?
Thank you for all
Yes.
the panelists.
Okay, we're wrapping up. Thank you.
Thank you for you as an audience. And there's one last message I want to share with you that I always share with people when we talk about big data analytics. And I think it's very important also in terms of privacy. No matter how good the data are, no matter how good the algorithms are, don't always trust the data. But as a lawyer, keep asking the why. That's very crucial in our society. Thank you, and enjoy the rest of the day.
And thank the panel. Thank you.